One of the many physical phenomena that occurs on Earth's atmosphere are the cumulonimbus clouds. This type of cloud is a dense, towering vertical cloud forming from water vapor carried by powerful upward air currents. Cumulonimbus can form alone, in clusters, or along cold front squall lines. These clouds can generate lightning and other dangerous severe weather conditions, such as tornadoes. Cumulonimbus progress from overdeveloped cumulus congestus clouds and may further develop as part of a supercell. Airline pilots, for example, are highly encouraged to circumvent these clouds. But what if an airplane gets inside these thunderclouds? Terrestrial gamma ray flashes are bright, sub-millisecond bursts of gamma rays produced within these cumulonimbus clouds. These emissions, that were discovered in 1994, are being recorded by astrophysics space missions such as Agile. Terrestrial gamma ray flashes are produced at the top of thunderclouds by avalanches of electrons, accelerated within thunderstorm-strong electric fields, and abruptly break in the atmosphere. Let me explain this in a more detailed way. First, electrons are produced within the clouds by some process, cosmic rays crossing the cloud, for instance. Then, the electric field produced within the cloud, due to the charge distribution between the top and the bottom of this, accelerate the electrons towards the top of the cloud. Next, during their course, if the electrons have enough energy, these will collide with molecules present in the cloud, producing more electrons. And finally, when they reach the top of the cloud, they get out of the volume where the electric field is defined and decelerate abruptly, being produced an exceptional amount of bremsstrahlung photons in the X-ray and gamma ray spectrum. Exhibiting energies from a few kilo electron volt up to several tens of mega electron volt, terrestrial gamma ray flashes are the most energetic phenomenon naturally occurring on Earth, and can represent a severe risk for airplanes and aircraft transports, both for the crew and the onboard electronics. So you may be questioning about the health risks this implies when you're traveling in an airplane. Airplanes have some radiation shielding in their structure, but despite this, energetic particles may penetrate the cabin and reach the crew and passengers. In order to assess the radiation risks resulting from traveling nearby these clouds, we can measure or simulate the radiation effective dose received by a person within the airplane crew. Essentially, the effective dose is the absorbed dose of radiation times the appropriate radiation weighting factors for all the tissues and organs of the body. And my work is to model these terrestrial gamma ray flashes interacting with an airplane. I will evaluate typical terrestrial gamma ray flash fluxes at commercial flight altitudes around 10 kilometers, the potential dose absorbed by the crew, and the probability of an airplane being caught by these flashes. In the end, I will hopefully have created a tool of major importance to assist the airline companies and flight safety institutions in the development of more secure and effective solutions for the crew and aircraft transportation. My name is Rúben Santana, and this was a brief overview of the work I will develop in the next semester for my master thesis in physics engineering at Instituto Superior Técnico from the Instrumentation and Experimental Particle Physics Laboratory in Portugal. I hope you enjoyed this short presentation and learned something in the meanwhile.